Let's go over some examples of SSA triangles, the ambiguous case. We will identify the category of the triangle. In these cases, they'll all be SSA, but I'll kind of show you how to determine that they are SSA. And then we're going to determine the number of triangles that are possible and then solve for those triangles if we can. So let's look at example 4 here. So how do I know that this is an SSA? Well, first I see that I have two sides and an angle. So that tells me that I'm kind of on the right track. And then the angle, it matches up with one of the sides, meaning that that angle B is across from this little b here with a length of 4. And so because I have two sides and an angle, and one of the angle is kind of pairing up with one of the sides, that tells me I am in the SSA case. Then I'm going to use that flow chart. So in this case, I see that this angle here, there's only one angle. It is given. It is obtuse. And so then I want to check out its corresponding side, which is b equals 4. Okay, so from an obtuse angle, its corresponding side should be the largest of the triangle. So let's see what we have. Well, we have little b here, and b is equal to 4, but it is smaller than this other given side, and that is not going to be able to make a triangle. So in this case, this is 0, results in 0 triangles possible. And so our work here is done. Let's move on to another one. We have a little more room to work, so that's showing that there might be a little more to do. So how do I know if this is an SSA triangle? Well, I have two sides and an angle, and the angle matches up with one of the sides, so little a across from big A, assuming we have big A, big B, big C, little a, little b, little c, in terms of what we are referring to our angles and our sides. Okay, I notice that the angle given to me is acute. It is less than 90 degrees. Okay, and the corresponding side that I have, so I check it's A, is larger than B. So this is larger than. So we have A is greater than B, and this case gives me one triangle. Yay! So since I'm have enough to determine a unique triangle, then I can just go ahead and fill in the given information. A is 50 degrees, the side of A is 3, the side of B is 2. So then my goal would be to find B, big C, and little c. So we can go ahead and do that. First, let's use law of sines to kind of complete my my pair. So law of sines really needs two pairs. There are 4 things altogether. I need to know 3 out of the 4 so I can just solve for the missing piece. So here I'm going to solve for angle B. So how do I do that? Well, I'm just going to use law of sines. So I'm going to have sine of 50 degrees should be over that corresponding length of 3. And then this is going to be sine of B, and then all over its length of 2. How do I solve for that B inside? Well, first I need to get it by itself. So I need to get as close as I can. So I can multiply both sides by 2. If I do that, I end up with 2 times the sine of 50 degrees all over 3 equals now the sine of big B here. Okay, and then when I do that, now I need to solve for B. Now this can be a little confusing. Wow, let's kind of slow it down here. Here's my input for sine, and here is the output for sine. Okay, here. And so if I want to switch those, okay, I can. And what would that look like? Well, then I would have the sine inverse of Okay, so it used to be on the outside. Now I'm going to put it on the inside. 2 sine of 50 degrees all over 3. Okay, and then that is going to be equal to my b. Okay, so all I've done is said sine of in was equal to out, and now I need to switch. So now b is out, and that whole thing that used to have its own side to be the out is now inside, and that can only happen when I'm using sine inverse. So I'm going to put this whole thing into Desmos in one swoop. So I'm going to pull that over here, and what do I need to start with? I start with sine inverse. So I go over to the function menu and select sine inverse. Then go back to main and use the division symbol to show you're going to enter a fraction. I want 2 times sine of 50 degrees. And then on the bottom, I just need a 3. I go over to the side to complete, and it's already calculated for me 30.71. So B is approximately 30.71 degrees. Okay, now how could I find big C? Well, I can't use my law of sines to find big angle C because I don't have little c to kind of go along with it, where I would need to kind of have both, or need to have one or the other. So in this case, I'm going to assume B is correct and then go ahead and solve for C just by knowing that the angles of a triangle need to add to 180. So if I'm solving for big angle C, I'm going to have C is 180 degrees minus the other 2. And I could do this by plugging that in exactly in Desmos of what it gave me before I could plug in that value. But I think this will get us close enough. 99.29 degrees here. Okay, so that's what I just found here. And then now we can take what's left to solve for little c, which is that side. And now I can kind of use a new, I can say, take this pair and this pair with its missing piece that I want to solve for and use law of sines. So I'll show you what that looks like. We're going to have sine of, so this is solving for little c, sine of 50 degrees all over 3 is equal to sine of 99.29 degrees. Again, that's not quite exact, but it's kind of the best we can do right now. Then I'm going to multiply, cross multiply. So I'm going to have c times the sine of 50 degrees equals 3 times the sine of 99.29 degrees. And then dividing both sides by sine of 50 degrees is going to get me that little c value. Okay, and then I can go ahead and put that into Desmos. So I'm going to have 3 times the sine of 99.29 degrees all over sine of 50 degrees. And I should get 3.86 for my value for, we're saying that's approximate. And again, that is the value that I just found for C right here. And that's this one there. And then I have solved that SSA